Hello everyone and welcome back again. Today we have an interesting question on motion under gravity. Let's solve it together. The question reads, a ball is projected vertically upwards with an initial velocity of 20 meters per second. How high will it go? That's the first question. How long will it take? When will it return to the ground? And finally, with what velocity will it return to the ground? We are asked to take g as 10 meters per second square. Okay, let's solve this question together. So we say solution. We collect our data. The initial velocity, which is v naught y, okay, the initial velocity in the y direction equals 20 meters per second. So this v naught y simply means the initial velocity in the y direction. Our g, which is acceleration due to gravity, is 10 meters per second square. For the first part, we were asked to find the maximum height, which is how high the ball is going to go. So this is the case, something like this. The ball is projected from this point, it goes up and then returns to the ground. Okay, so this point is the maximum height. And we are asked to find the maximum height or how high it will go. So whenever you're asked to find how high it's going to go, you're basically being asked to find the maximum height. Okay, now one other thing that you need to know is that at the maximum height, the final velocity is always zero. Here, v final in the y direction is always zero at the maximum height. So don't forget that. Here we have three equations. The first one is Vy is equal to V naught y plus or minus gt. This is the first equation of motion. And for the second one is y is equal to V naught yt plus or minus half gt squared. And lastly, we have Vy squared equals V naught y squared plus or minus 2gh. Okay, so we're going to use these three equations to solve this problem. Now, looking very closely with the information we have, we were asked to find the maximum height. So looking very closely here, we have our initial velocity, we have our g, we have our final velocity, because Vy is equal to 0 meters per second at the maximum height. But we don't have h here, so we cannot use this one. We don't have time as well, so we cannot use the second one. So here, for the second one, we have the initial velocity in the y direction. We have our g. We don't have the time, so we cannot find our y because we're going to end up with two unknowns. For the last one, we have the final velocity in the y direction. We have the initial velocity in the y direction. We have our g, so we can find our height. So let's use the third equation to solve for height. Here we have our third equation, which is Vy squared is equal to V naught y squared plus or minus 2gh. Since it's going upwards, we choose g as negative. Now it's going against gravity, so g becomes negative. At the maximum height, the final velocity is 0, so this becomes 0 squared is equal to the initial velocity is 20, so this becomes 20 squared minus, here we have a 2 multiplied by our g is 10, then multiplied by the height. So here 0 squared is simply 0, and this equals 20 squared is 400. 2 times 10 times h, this gives us minus 20h. And again, we can move the negative 20h to the other side. So we now have 20h. When it crosses over, the negative sign changes to positive. This is equal to 400. Okay, so we simply divide both sides by 20. and we divide both sides by 20, the height now becomes 400 divided by 20, and that is 20 meters. So the maximum height is 20 meters. How high it's going to go is 20 meters. And then for the part B, we were asked how long will it take? So this question refers to how long it's going to take to get to this very point, okay? How long is it going to take? That is the time it takes to reach the maximum height. Now, which of the three formulas should we use again? We want the one that has time. So we can use the first one because we have the final velocity in the y direction. We have the initial velocity in the y direction. We have our g. We can solve for time. Okay, even the second one will also do. We have the maximum height. We have the initial velocity in the y direction. We have our g. We can still solve for time. But for simplicity, let's use the first one. So for the first one, we have Vy equals V naught y plus or minus gt. So since it's going upwards again, we take g as negative. So this becomes 0, because at the maximum height, the final velocity is always 0. This is equal to, the initial is 20, then minus our g is 10. This is multiplied by t. So here we have 0 is equal to 20 minus 10t. Moving the t to the other side, we have 10t is equal to 20. We divide both sides by 10 to solve for t. We have that our t, 20 divided by 2 is 2. 20 divided by 10 rather is 2. So here we now have that the time taken to reach the maximum height is 2 seconds. Okay, now the next question is, when will it return to the ground? Okay, when exactly is it going to return to the ground? So now we are currently at the maximum height. We're here at the maximum height, so we can use the information that we have to find the time it's going to take to go from here to here. Okay, so we found from here to here, which gave us 2 seconds. So we can also find from here to here, okay, and then we add them together. But we can also decide to use the initial velocity to find the total time. It is still possible. So let's see what we can do in this very case. We can either use the first method, which is from the maximum height down, or we can use everything. So let's see what we can do. We are going to use from the maximum height, but we need to know that at the maximum height, the initial velocity is still 0. So at the maximum height, the final velocity is 0, and the initial velocity is still 0. Okay, so this is because it's going to stop momentarily before crashing to the ground. So we say that the initial velocity in the y direction from the maximum height is simply 0. So let's see which formula that we're going to use. So right here we have, we're looking for the time. We have the height. We have the initial velocity, which is a 0. Do we have the final? No, we don't have the final yet. So let's see which one again that we can use. Here we have the height. We have the initial velocity in the y direction, which is a 0. So we can use the second equation. Okay, so this is for part C. So we use the second equation of motion, y equals v naught yt plus or minus half gt squared. Okay, so right here, I'm going to take g as a positive because the ball is now falling to the ground. So we have our height to be 20. This is equal to the initial velocity in the y direction at the maximum height is 0. So 0 multiplied by t, then plus half. Again, our g is 10. We have t squared. We're looking for the time from the maximum height. Okay, not from the origin, but from the maximum height. That's what we're actually looking for. So here we multiply 0 times t is 0, and then half of 10 is 5. So we now have 20 is equal to 5t squared. So to solve for t squared, we simply divide both sides by 5. They cancel out, and then t squared is equal to 20 divided by 5 is simply a 4. To solve for t, we can square both sides. So t squared is equal to 4. We square both sides. This square goes away with this. Then t is equal to plus or minus the square root of 4. T is equal to plus or minus 2. Okay? So the square root of 4 is a 2. So we take the positive time because time can never be negative. So t is equal to 2 seconds. So this is actually from the maximum height. So we say here we have, for the first part, we found T1, I would say T1 was 2 seconds and T2 was 2 seconds as well. So here we have, since it's the same, so we say that T is equal to T plus T. And this is equal to T plus T is 2T. So the total time is equal to 2. Since our T is 2, so this now becomes 4 seconds. So it's going to return after 4 seconds. All right. Now, for the last part, with what velocity will it return to the ground? So we're actually being asked to find the final velocity when it falls to the ground. Okay, so let me try to make some space here so that we can solve it from here. This is the part B of the question. Okay, so we're asked to find the final velocity, and we need to understand that velocity is a vector, and when it's going upwards, it's a positive, but when it's returning to the ground, it's a negative. Don't forget that. So, which equation are we going to use right now to find our final velocity? Here we have the Vy. Okay, this is the final velocity. We have the initial. We have our time, which is 4 seconds. And we also have our g. So we can use the final. We can use the first equation of motion to solve for the final velocity. So we say Vy is equal to V naught y plus or minus gt. Okay. Again, we say Vy is equal to V naught y minus gt. So I'm using the negative in this case because I'm going to use the initial conditions. Okay. So whenever you're using the initial conditions like the initial velocity and what you started with, so the g has to be negative. Okay. We want our velocity to be negative. So if you're using the initial conditions, then your g has to be negative. Don't forget. So the final velocity Vy is equal to the initial velocity is 20 minus our g is 10. Then this is multiplied by the total time, 4 seconds. Now we have, let me make some space here so that we can understand clearly what's going on. Here we have Vy is equal to 20 minus 10 times 4 is 40. So the final velocity is 20 minus 40, that is negative 20 meters per second. And this is the solution. This velocity is a negative value or has a negative value because it is a vector. So vector quantities, they have both numerical value or magnitude and direction. When it's going up, the velocity is a plus. When it's coming down, the velocity is a minus. I'm not talking about acceleration due to gravity here. I mean the velocity. When the velocity is going up, it's a plus, and when the velocity is coming down, it's a negative. Okay? I hope this video helps you. Thank you, and see you in the next video. Bye.